Right. All right. All right. Good evening. Can you confirm whether I'm audible, students? I'm audible, students? Okay. Right. Yeah. Fine. Okay. Right. Okay. So let's start. Let's start now. It's 7. Okay. It's 7. But today it seems still the students are joining in because today we are having a seminar, a free seminar on traveling microscope. That is the last measuring instrument we are going to discuss, right? We have finished all measuring instruments up to traveling microscope, namely meter ruler, vernier caliper, micrometer screw gauge, spirometer, and today we are going to finish the last measuring instrument we have, traveling microscope, right? Even though that is last, that is very unique and a very important measuring instrument that you are going to discuss today. Yeah, so it seems some students are still joining. I'll wait for another 2 minutes and then start, right? Just 2 minutes. Okay. Right. Good evening again. We'll start. We'll start. Right. So before moving on to the traveling microscope, the new lesson we are going to discuss today. From last day, what are the homework questions I gave? What are the homework questions I gave? Is it exercise 4? On to you. Is it exercise 4? Students? Was it exercise 4 that I gave you? Anyone? Play. Again. My homework question is exercise 4. Yes, exercise 4. Okay. So I hope everybody of you has done the homework, right? The homework is from spirometer. The last part we last measuring instrument we discussed last day, right? So I hope all of you have done the homework question, right? First, let's go to the discussion of the homework question, and then we are going to start traveling microscope. And after today's lesson about traveling microscope, today we will cover the full lesson of traveling microscope with everything you need to know about traveling microscope. So after this lesson, after this session, you will get to know everything about traveling microscope that you need to know, right? So simply the full lesson, full part of traveling microscope will be covered within the lesson, right? So therefore, stay vigilant, stay in the class actively, and cover the full lesson because now after this lesson today about traveling microscope. No need to go through theory parts and questions again about traveling microscope because we will be discussing and we are going to discuss all questions about traveling microscope with the theories as well. Right? When it comes to traveling microscope, there are like few types of questions coming. So other than that, mostly statement types questions are coming. Statement types when it comes to MCQs, right? And plus the structured essays. So therefore, we'll be focusing more on those areas when the discussion goes on, right? Now let's go to the discussion of the spirometer question I gave you last day, right? Exercise 4. Go to exercise 4. What's the page? Page number 5. Page number 5. Page 5. Exercise 4. Right? Page 5, exercise 4. Okay. It says, figure A shows the positions of scales of a spirometer when its all three legs and screw tip is taken to a single horizontal plane. Right. Figure B shows an occasion where a depth of a hole is measured. Right. So last day we discussed about it in a very comprehensive manner. Right. So we know before taking any measurement from a spirometer, right? Before taking any measurement from a spirometer, as the first thing, you have to take all three legs and the screw tip to the same horizontal plane. For that, we are using a glass block in the laboratory, right? In the lab, we are using a glass block. 1 second. Right? So in the lab, we are using a glass block, right? And when we do so, if vernier zero in the sense that is on the circular scale, vernier 0 and main scale 0. Main scale 0 is on the linear scale of spirometer. Are coincided, there is no zero error in the instrument. But if not, there is a zero error in the instrument. Right? Now the question says, figure A shows the positions of scales of spirometer when its all three legs and screw tip is taken to a single horizontal plane. Which means that is the occasion where it checks the error. Right? That is the occasion where it checks the error. Now, when the error is checked, you can clearly see that linear 0 and circular scale 0 are not coincided. So, which means this instrument has an error. This instrument has an error. Right? Keep that in mind. That is what figure A shows. And then it says figure B shows an occasion where a depth of a hole is measured. Depth of a hole. So, we know we can use a spirometer to take few measurements. One is thickness, right? For thickness measurements, spirometer can be used, and for depth measurements, spirometer can be used. Other than that, the most unique and the special measurement that can be taken by the spirometer is radius of curvature. Radius of curvature of any curved surface, right? So basically, these three are the three measurements we are taking from a spirometer. And this question is about taking a depth using a spirometer. Right. Question 1, part 1, it says, what's the value of error this instrument has? Okay. So I hope you have completed. Yeah, tell me, what are the answers you got for the first one? Students? Yeah, for the first one, what are the answers you have got before I discuss the question? Yeah, what are the answers you have got before I discuss the question? 0.3, 0.3. Okay. Since there are some new students also joining to the free session, since you don't have this question with you, I'll draw the given diagrams. Given diagrams are the scales, diagrams of scales here on the board for your reference. Right? You also can write a question with me before we go to the discussion of traveling microscope, right? So as figure A, this is given. As figure A, this is given. You also can copy it down. You don't have the tube. Right? This is given as figure A. And then this is given as figure B. This is given as figure B. For your reference, if you are a newcomer, just join for today's traveling microscope discussion. Right? You also can try this and check your knowledge. Point three, okay. Okay, first question. First, value of error the instrument has. See. Okay, if I quickly recall you about the theory part involved here, the theory part is, so there are two types of errors can happen in the speedometer as well, right? One error is when the circular scale 0 is, so the circular scale is above the linear scale 0, right? If that is above linear scale 0, we are reading the error as number of coincided divisions into least count, right? If there is below linear scale 0, the error is read as total number of divisions in circular scale minus coincided number of divisions in circular scale, the whole thing into least count, right? In speedometer, unless we know the reading we are going to take from the instrument, we can't say whether it's a negative error or a positive error, right? So unlike other instrument, in speedometer, we can't say it unless we know and unless we have an idea about the reading you are going to take. The reason is speedometer is having a center 0. It has a center 0, and readings are taken to the both sides, both directions, above 0 and below 0. So in those two cases, the error works accordingly in two ways. So it has two behaviors, right? Simply the reason is that. Right? Okay. Now this error. See, you can clearly see this is above main scale 0, right? This is above main scale 0. So if there is above main scale 0, error is read as number of coincided divisions. Number of coincided divisions in vernier scale into least count, right? Number of coincided divisions in linear scale is in vernier scale is 30 into least count. We proved the least count of a speedometer last day. We proved it last day, right? So if anyone can't remember, if there's anyone who can't remember, this is how the least count of speedometer is proved. Least count. Least count can be written as pitch over number of divisions in vernier scale, right? So pitch of the instrument is, we discussed last day, 1 millimeter. Pitch of the instrument is 1 millimeter, and number of divisions in vernier scale 100. So it gives us 0.01 millimeters, right? So therefore, first thing is least count of a speedometer is 0.01 millimeters. Least count of a speedometer is 0.01 millimeters. That you can find like this. And since we discussed this last day, right, you can use this directly. That is totally fine. Okay, into least count 0.01 millimeters. Simplify this. It says 0.30 millimeters. So the error this instrument has is 0.30 millimeters. 0.30 millimeters. Right? Now, as I told you, mentioning the zero is also important. Mentioning about the zero is also important because in measuring instruments, 0.3 and 0.30 are two different readings, two different values, right? So since we have the least count to 2 millimeter decimals, 2 decimal millimeters, we have to keep all the readings up to 2 decimal millimeters. Now here also it should be 0.30 millimeters, right? Don't just write 0.3, right? I have told you these things from the first day of measuring instruments. They are valid everywhere. They are valid everywhere. Okay, we will take it down. Take it down quickly. Next one. What's the apparent reading of figure B? Right here. What's the apparent reading of figure B? Now, when you deal with spirometers, we know when we read readings also, there are few things to be followed. There are few things to be followed. Right? They are now the way we are reading a reading which is above zero is different from the way we are taking a reading below zero. Now here a thickness is measured, sorry, a depth is measured. No, it says, the question it says a depth of something is measured, right? So we know when the depth is measured, you have to rotate the screw tip and you have to take down the screw. So therefore, it starts going down from zero. It starts going down from zero. So therefore, if a depth is measured, your circular scale will be below zero, right? Then maybe it will be below zero. I mean, below zero diagram में दिला दिया नहीं है. That should be below zero. The below zero diagram is given, right? Okay. So before I do, tell me what are the answers you got for part two, students? Okay. What are the answers you got for part two? Apparent reading of figure B. 4.20. Others? One says 4.20. Others? 4.20. Right? What else? 4.20. 4.20. 4.20. Okay, it seems everybody of you has got 4.20. Okay, let's see. Let's see whether it's correct. What's the apparent reading of figure B? Right. 4.20. Okay, good. Let's see. Okay. So we know any reading of a instrument which uses vernier scale is read as main scale reading plus vernier scale reading. Right? So this is also main scale plus vernier scale. The reading is also main scale plus vernier scale. Right? So let's say these are, let's say R. Main scale is read as completed main scale divisions. Right? Main scale is read as completed main scale divisions. And if this is below zero, you can see here, zero is here. This is below zero. So if there is below zero, when taking a reading also, you have to take the vernier scale as total minus coincident number of divisions. Right? Very important. Total minus coincident number of divisions. So it is like this. Main scale plus this is total number of vernier scale divisions minus coincident number of vernier scale divisions. This whole thing into least count. This whole thing into least count. Right. See, Main scale. Main scale is always the completed main scale divisions. Right? Main scale is always the completed main scale divisions. See? 0 here. 1, 2, 3, 4, 5. So 4 are completed. 5 is not completed. Only 4 divisions completed. So we know main scale of a sperometer is in millimeters. Millimeter divisions. So therefore main scale is 4 millimeters. Plus here total number of vernier scale divisions. So before also I explained you the same. Total number of vernier scale divisions here is 100. 100 minus coincided number of vernier scale divisions. Coincided number 80. 80 times least count 0.01 millimeters. Simplify this. 18 equals 4 millimeters plus 20 times 0.01 millimeters. Right? R equals 4 millimeters plus this is 0.20 millimeters. Right? It means R equals 4.20 millimeters. Apparently 4.20 millimeters. Yeah. Most of your answers are correct. Good. Take it down if there's anyone who didn't try that part. Take it down. Okay. What about the next one? Determine the actual depth of hole. Determine the actual depth of hole. What are your answers, students? What are the answers? 4.40. Others? Actual depth of hole. One says 4.40. Others? Quickly. What are the answers? Actual depth of hole. 3.90. Others? Yeah, for that I can see you have got different answers. What's the reason? What about others? What about others? Now I got two different answers. 4.40. No, three different answers. 4.40, 4.30, 3.90. What about others? What do you say? Four point zero zero. Four different answers. What's the reason? Everybody of you should get the same correct answer, right? Everybody of you should get the same correct answer. Now I can see four different answers. Why? What's the reason? Huh? The reason. Any other answers? No? Come on. Any other answers? Quickly. Quickly. Any other answers? Any other answers? Students? No? That's all. That is it. Is that not it? That's all. Huh? That's all. 3.90. Okay. That's it. That's it. Okay. Now depth of a hole is measured. Look at here. Look at the board. Okay. Look at the board. When all three legs, when all three legs of the spherometer, when all three legs are, when all three legs of spherometer are on the same horizontal plane, your reading goes like this. It goes here, right? When all three legs of spherometer, listen, when all three legs of spherometer was on the same horizontal plane, this is how your scale was. This is how your scale was. And when the depth is measured, this is how your scale was. This is how your scale was. Right? Then depth of the hole should be, right? Depth of the hole should be from that horizontal level to the bottom of the hole. Right? Then it starts from this horizontal level. Starts from the horizontal level. And it should be up to here. This is the depth of the hole. Up to here. That is the depth of the hole. Right? This reading always give us the reading with respect to 0. But initially also it had a reading above 0 like this. Right? Can you see? Because this reading measures are look at the board. You didn't get the correct answer. Look at the board with this diagram here. Look at here with this diagram. Very important. This reading is from here to here. Reading is from here to here. R is from here to here. Right? And we had an error. We had an error here. That error was 0.30 millimeters. Right? This is the error. So the error part is from here to here. This is E. Error. Right? Now what we need is actual reading. 3. Actual reading. So therefore, the actual reading is going to be depth. Or the actual reading. The actual reading is going to be R plus E. R plus E. So let's say R dash. That is that R plus E. What's the reason? What's the reason? Actual reading has to be the actual depth of the hole. Actual depth. Now, it is supposed to start from 0 if there was no error. But now, it had an error. The instrument has an error. Since the instrument has an error, right? It is not starting from 0. It is starting from here, somewhat above 0. And from that above 0 point, it's coming all the way up to here. So the reading has to be this, right? So therefore, this error should be added to the reading. This error should be added to the reading. R is 4.20 millimeters plus E is 0.30 millimeters. So actual reading, final reading is 4.50 millimeters. Actual reading or the final reading is 4.50 millimeters. Right? So likewise, in the spirometer, with respect to the reading, the error changes. With respect to the reading, the error changes. Right? Now, when you measure a depth, this acts as a negative error. When you measure a depth, this acts as a negative error. But using the same instrument, if you measure a thickness, it starts from here and it's going upwards. So therefore, in that case, it acts as a positive error. Same error acts as negative and positive errors with respect to the reading you are going to take. Right? Whether it's moving upwards or downwards. Downwards move, you are reading a shorter reading. So therefore, this acts as a negative error. A positive correction should be done. But if you move this upwards, thickness make upwards move. Right? Because it starts from here. This is where all three legs are on the same plane. Right? If you are moving this upwards from this point, moving upwards from the plane, what happens is the same mirror works as a positive error. Right? 0 will start counting, 30 will start counting. So it works as a positive error. So therefore, that is something you have to be vigilant on that. Right? That is something you have to be vigilant on that. So should not we find the error for the second one? Second one means yeah, what do you mean by second one? Figure B. Figure B is the same instrument. That is a different occasion of same instrument. So same error is in that instrument because that's the same instrument. Read the question. Right? Take it down. And if you have any questions, you can ask and clarify them. If you have any questions, you can ask and clarify. Right? If you are on Zoom or YouTube, that doesn't matter. I can see both chat boxes. So you can ask questions if there's anything to know. Take it down. Okay. Is it clear enough? Students, is it clear enough? Okay, others? Is it clear for all of you? The final answer, actual reading is 4.50 millimeters. 4.50. So can you explain one more? Okay. Listen again. Listen again. Listen again. Now the instrument, if the instrument is ideal in the sense if the instrument has no error, it should start from 0, right? If the instrument has no error, it should start from 0. And when it measures depth, right, ideally it should start from 0 and come down. Right? Ideally it should start from 0 and come down. But now in this case, since this instrument has an error, it is not starting from 0. It is starting before 0. Right? It is starting before 0. Somewhere like this. It is starting before 0. And starting before 0 and it is coming down all the way up to this point. Right? Then that whole height should be the depth of the hole. Right? 0 it's supposed to be start from 0. 0 in Tamaya started if there is ideal. But now it is not starting from 0, it is starting above 0. And from that above 0 point, it is coming down. Right? Then that whole height, whole difference has to be the depth of the hole. Right? The reading always give you the value with respect to 0. Reading again is 0. Reading always give you the value with respect to 0. Right? Reading is given with respect to 0. Right? Reading is given with respect to 0. Now, that's the thing. Then reading is measuring the value from 0 to here. Right? Reading is measuring the value from 0 to here. And error is the value of this part here. මේ part එක මෙන්න මේ part. මේ part එක තමයි error එකේ තියෙන්නේ. මේ part එක තමයි error එකේ තියෙන්නේ. මෙයාට මේ error එක add කරොත් මේ total height එක ඔයාලට ගන්න පුළුවන්. Right? So if you need that total height is the addition of the reading here, this part here plus error. Right? So actually, now for this reading, this is a positive correction. This error is a negative error for this reading. Because we are measuring a depth. For the depth measurement, that is a negative reading. Negative error. Negative reading. For the negative error. Since there is a negative error, a positive correction should be done. Okay. Any other questions? Any other questions? Okay, clear. Let's move on. Just know this for your reference. See, I'll read this again. You got the board? I'll read this again for your understanding again. See, I'll read this again for your understanding again. Now, if you have this kind of an error in the instrument, see, note. Now, if you have this type of an error in the instrument, see, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Say you have this type of an error, right? This type of an error, where the circular scale is above main scale 0. Circular scale is above main scale 0. Now, when it comes to this error, if you are taking a reading upwards, upward direction from this position, for upward direction readings, it's going to act as a positive 0 error. Right? Because it is starting from here. Suppose you start at 0, but now starting from here. And it's moving upwards. Right? So therefore, it acts as a positive 0 error. Right? For this direction, like if you measure a thickness, it acts as a positive 0 error. Right? And using the same instrument, if you measure something downwards, depth, it acts as a negative 0 error. Acts as a negative 0 error. Right? And the next type is type 1. This type 1. And next type is, if you have this type of an error, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. If you have this type of an error, right? Below main scale 0. Right? Now, here on, if you measure a depth like this, now from the below side, the reading is already gone. It's already gone for some value. So therefore, for this depth, this becomes a positive reading, positive error, positive 0 error. And if you measure a thickness in this direction, starting from here, thickness, of that. Now thickness, there is a -0 error. Now according to these errors, you have to do corrections. According to these errors, you have to do corrections to get a correct reading, the actual reading. Right? So write this down as a note. This is what happens. This is what happens. So that is why thinking about error in a speedometer is a little bit different from the other instruments. In other instruments, error is defined. In other instruments, error is defined. Defined in the sense we can say whether it's a positive error or negative error just by looking at the error. But in speedometer, you can't say whether it's a -0 error or +0 error just by looking at the error. It depends with respect to your reading, like this. It depends with respect to your reading, like this. Right? Take this down in a clear manner. Take it down in a clear manner. Take it down in a clear manner. So if you are using different colors, use some different colors. Okay. Okay. Any other questions? Any other questions? Or is it clear enough? Put a thumbs up at least if that is clear for you. Right? How about the students on YouTube? How about you? Got it. Okay. Clear. Okay. Fine. Yeah. Okay then. Okay. Okay. Then that's it for sperometer parts. Right. Now let's go on to the new part today, new lesson today. That you are going to learn. That is the last measuring instrument you are learning out of 5 instruments we had. Right. Last of the 5 instruments we had. 5 of 5. Last of 5. That is traveling microscope. Take down the heading as traveling microscope. Take down the heading as traveling microscope. Traveling microscope. Right. Okay, listen now. Listen. Listen first. Right. Now, you have seen microscopes, no? Right? In grade 6, grade 7 science. 6, 7, 8, oh, I don't know. Before levels, in grade 6 or 7, you have seen microscopes, right? The normal traditional microscope, you have seen microscopes. Now, this is also a microscope, you can see. That is also a microscope. Basically, tell me, what's the purpose of using a microscope? I'm not asking about traveling microscope. What's the purpose of using a microscope? You have a little bit of an idea about microscopes. No? What's the purpose of using a microscope? Tell me. What's the purpose of using microscope? For what a microscope is used? Zoom. One says zoom. Correct. What else? Yeah. The idea is correct. Your idea is correct. If you need to have a magnified view of something, a magnified view, an enlarged view, right? To see object through zooming, to observe things which are not seen to our naked eye. Good, good, right? Yeah, good, very good. To see object through zooming, yeah, right. So the idea is, if something is not in our visible range of the naked eye, right? And if we need to get an enlarged or a magnified image, right? Enlarged or a magnified image, microscopes are used. Right? Microscope එකක් use කරන්නේ නිකන් naked eye එකට පේන එකක් බලන්න microscope එකක් use කරලා වැඩක් නෑ. දැන් මම මේ pen එක බලන්න microscope එකක් use කරන්නේ නෑ. Right? So that is clearly visible to the naked eye. Right? So therefore, if you need to look at something, if you need to observe something with an enlargement, with a magnification, right? We call magnification. With a magnification, we will use a microscope, right? Now, this is a traveling microscope. So traveling means it should be something movable, right? The word traveling in the sense traveling or moving, dynamic, right? So which means there is something moving. That is about something moving. So basically, right? So before starting, just know that traveling microscope has a microscope, right? It's a microscope. Traveling microscope has a microscope, and especially that microscope part can be moved here and there, right? So we will see how you can move the traveling microscope when we are going to take a reading in the coming parts, right? So because of that movement, it says it's a traveling microscope, right? Okay. So first thing is, let's identify the parts of traveling microscope. And after identification of parts, we will see what are the unique measurements, unique readings that are taken by a traveling microscope, and why the traveling microscope is very much useful and important over other four instruments when we use it to take a measurement. Right? Those are the parts that we'll be covering today. Right. So first, we will see the parts of traveling microscope. Right. So after the diagram, then I will show you a traveling microscope as well. Right? See. First, let me draw this. Okay. Just look at the board. Don't draw anything. Right? I'll give you time to draw. Just look at the board. I'll give you some time to draw. I'll give you some time to take this down. So until then, no need to know this. Just look at the board and try to understand. Try to see what's happening here. Right? Just look at the board. That is enough. Just look at the board. That is enough. Right. Okay. Right. Okay. Look at the board. Look at the board. Right here. Look at the board. Okay. So when you take this down also, if needed, you can use different colors for your clarity. Right? If you are referring this again, when you are referring this again, it should be totally clear to you. It should be 100% clear to you. Right? So therefore, have a clear diagram when you are also copying down. Right? First, let's see these parts. Let's identify these parts. Look at here. Look at here. Now, main part of the traveling microscope is microscope that I have told you already. Main part of a traveling microscope is the microscope, right? And this is the microscope part. Microscope part. Look at the board. This is the microscope. This whole thing, huh? That is a microscope. And we know if there is a microscope, any microscope has two lenses. Two lenses. Right? There is one lens to project it to the object. That is called the objective piece. and there is another lens to keep our eye, right? There is another lens to keep our eye like this. So we will be keeping the eye at the eyepiece, right? Eyepiece, and we will keep the object in front of the objective piece or objective lens, eye lens and objective lens, or eyepiece and objective piece, right? Here also, this piece here, this lens here is to keep the object. We will keep the object in front of this, in front of this. So therefore, this is called objective piece. And this is to keep the eye. That is called eyepiece. That is to keep the eye. That is called eyepiece. Right? And this nut type of thing here, nut එකක් නෙමෙයි, nut එකක් වගේ. There's a grip also, and it is rotatable. ඒක rotate කරන්න පුළුවන්. Right? That is called the adjustment of microscope. When this is rotated, what happens is the length between eyepiece and objective piece is varied. It's changing. Right? That is called the adjustment of microscope. Microscope එක adjust කරගන්න ඕන වෙලාවට තමයි මේක use කරන්නේ. Adjustment of microscope. This is called the adjustment of microscope. Adjustment of microscope. Right. And look at here. Can you see there are two main scales in this instrument? There are two main scales in the instrument. One is a vertical scale and another one is here. That's a horizontal scale. One specialty and one unique feature of the instrument is that in all other four instruments we discussed so far, there was only one scale, right? If that was a vernier scale used measuring instrument, there was only one vernier scale, right? Here there are two vernier scales. Two vernier scales. That is the only instrument you have with two vernier scales, right? That's a specialty about a traveling microscope. And one vernier scale is vertical, whereas the other one is horizontal, right? So therefore, this is called vertical main scale. Vertical main scale. And this is called, this part, this is called vertical vernier scale. Vertical vernier scale. And similarly, this is called very similar. This is called horizontal main scale. Horizontal main scale. And this is called, this part, this is called horizontal vernier scale. Right? We will see the purpose behind having two scales, right? So just be patient. We will see the purpose of having two scales, right? And then, look at here. There is another nut here. There's another nut here. This is a nut that is rotatable. That is rotatable. That is called fine adjustment of vertical movements. Vertical movements, which means, look at here. Now, microscope is fixed to this part here. For this black frame, microscope is fixed, right? Now, by rotating this microscope part, this whole part can be moved up and down, slowly using this. Since that is used for the slow movements, that is called it fine movement. Slow movements are called fine movements. This is the adjustment for fine vertical movement. See, this is the adjustment for fine vertical movement. Adjustment for fine vertical movement. Right? Fine in the sense, when we rotate it, this part travels slowly, fine movements, right? And if we need to move it faster, there is another method here. Listen now, listen. If you need to move it faster, there is a method here. There's a method. the method is, this part is like a small lock. There is a lock, right? So once we unlock that, we can move this part up and down by force. By force in the sense, you can grab that part and move it up and down, right? This is a lock. This is a lock. Once that lock is unlocked, this part is free to move just by using hands. Using hands move around, right? And there is no faster movements. Now, if you need to take it from here to here at once, we can unlock the system from here, unlock the part from here, frame from here, and move it down, take it down by manually applying a force on it. Applying a force in the sense you have to grab it and manually take it down. You have to grab it and take it down. That is called a force movement. Force movement. So therefore, this is called adjustment for. Look at here, don't write anything. Very important. Adjustment for. This is called adjustment for, not find. That is called force. Adjustment for force vertical movement. Adjustment for force vertical movement. Right? Same mechanism is there for the horizontal movement as well. Horizontal movement happens like this. Now, this entire part, you can see from here. This entire part is like a sand bedding. This is like a sand. This part can be moved horizontally from here to here. This entire thing, no? This thing goes like this. This entire part can be moved horizontally like this. Right? This entire part. This pillar. Whether pillar is a pillar. This pillar can be moved. Right? So when there is move, this scale works. When there is move, this scale works. So therefore, for those movements, these two adjustments are there. This is the similar adjustment as this. It's the adjustment for. Adjustment for. Find horizontal movement. Find horizontal movement. Adjustment for find horizontal movement. And similar mechanism for force movements are also here. This one. This is a lock again. This part is a lock. Once that lock is unlocked, this is free to move manually here and there in a faster manner. Right? Unlock you can grab it and move it manually. That is called the force movement. So this is for this one, huh? This one. I'll label it here. This is the adjustment for force horizontal movement. Adjustment for force horizontal movement. Okay, not over yet. Look at here. Adjustment for force horizontal movement. And here, these are 1, 2, 3, 4. There are 4 legs like this. 4 legs. There are 4 legs like this. They are called the screw legs. They are called the screw legs of traveling microscope. Screw legs in the sense, now when we need to adjust the height, we can rotate this part and adjust the height. Screw legs, so that is also called leveling screws. Both are fine now. Leveling screws. Leveling screws in the sense, you can rotate it and adjust the height of the screw. They are the legs of sperometer, of traveling microscope. Right? They are called, look at here. They are called leveling screws. Leveling screw. And this is also a leveling screw. There are 4 leveling screws. Huh? Right? And this is also leveling screw. This is also leveling screw. Right? Let's say A, B, C, D. All A, B, C, D are leveling screws. All A, B, C, D are leveling screws. Next. All ABCD are level instruments. And the next thing is the most important, another most important part in the instrument that is here. That is the spirit level. That is a spirit level. This part, this part here is a spirit level. Have you seen spirit levels? Oh, spirit levelers. Have you seen spirit levels, students? Usually, masons are mostly using. If we need to check about a level, right? Have you seen an instrument we have with a air drop, with an air drop inside a liquid, something like this? Something like this. This is an air drop or air bubble. This is an air bubble. Air bubble in a liquid like this. You have seen, right? And when we need to take a level, right? If that air bubble is exactly at the center here, which means that is horizontally leveled, right? That is the idea. That is the idea. Same mechanism is inbuilt here. Same mechanism is inbuilt. හරි මේකම inbuilt කරලා එනවා. අපිට මෙයාව level කරගන්න ඕනලාට spirit level එක දිහා බලලා level කරගන්න පුළුවන්. Once you need to level the instrument, you can easily look at the spirit level here and get an idea about the level of the instrument. And by checking the level, we can adjust these leveling screws and take it to the same horizontal plane. Right? Okay. So these are the parts of a traveling microscope. These are the parts. These are the parts of a traveling microscope. Yes, sir. Yes, sir. Okay. These are the parts of a traveling microscope. Right? So first, I'll give you like 4-5 minutes. Look at the board carefully, right? And very mindfully. And take it down in a clear manner. If you are using different colors, use different colors and take it down and label it accordingly. Right? Starting. Draw a proper diagram. Draw a proper diagram. Start it. Take it down. And if you have any questions, you can ask. If there's anything to clarify, please ask. So now only I noticed recording is not on. Yeah, that's fine because now today the session is streamed on YouTube. It will be on YouTube anyway. So that's why I didn't record it on Zoom. Right? Thanks for reminding. Thanks for reminding. Take it down. And tell me once you finish. Tell me once you finish. I'm staying a bit aside because to you to see this entire diagram properly. Right? I'm staying a little bit aside to see the diagram properly. If you have any questions, you can ask. If there's anything to clarify, you can ask. Take it down in a very clear manner. Take it down in a clear manner. Someone, what about the diagram today? You should draw these diagrams properly, right? So as physics students, you should be able to draw these diagrams properly, yeah? Right? Master diagrams are in them. Finished? Finished? Okay. Okay. Take it down, take it down. And listen, students, as I told you last day, uh, next week we are starting mechanics. We are starting unit 2, right? By today, unit 1 will be finished. After finishing tandem microscope, unit 1 will be finished, right? So after finishing unit 1, now next week we are starting unit 2, mechanics. One of the crucial lessons, right? One of the crucial lessons in the syllabus, because that is the lesson with, that is the unit with highest number of links with the other units. A crucial lesson. So next week we are studying mechanics. So if there is anyone who is willing to join to the class, pass the message. If you have any friends or colleagues, you can pass the message. I'll share a flyer during the week as well. So you can share flyers and you can pass the message if there's anyone who need to join next week onwards, right? Because we are starting unit 2, one of the most critical lessons, and don't miss any classes from the day 1 onwards about unit 2, because they are very much linked, interlinked. They are very much linked to each and every part. So therefore, when we build this up from the beginning, from the scratch only, we will get everything in a proper and a clear manner. So therefore, don't miss any classes in mechanics especially. Right? Very important. All the things are linked. Okay, take it down. Finish it. Finish. Done. Others? Who is still drawing? Who is still drawing or has everybody of you? Has everybody of you finished it? 2 minutes. Okay. Finish. Now take it down. I'll give you like 3 more minutes. I'll give you 3 more minutes maximum. Finish it. Finish it. This is the spirit level. This is called the spirit level. Spirit level. Oh, spirit level. Spirit level. It's a very popular instrument among masons because they are using it to check the levels of walls, vertical and horizontal walls. When they build walls, right, they need to check the vertical level and horizontal level of walls. There is one usage of it. Other than that, in camera tripods, right? When you place the camera to check whether it's exactly horizontal, usually spirit levels are inbuilt in cameras or camera tripods. So likewise, there are different occasions. Right? Since there are hand lens attached. Since there are hand lens attached. Hand lens is attached in some traveling microscopes to see these readings, the divisions in a clear manner, but not in all. In some, yes. Right? That is not a mandatory part. That is not a mandatory part. Yeah, you are correct. In some traveling microscopes, a hand lens is attached here, a small hand lens. Right? In some instruments only. So therefore, I haven't drawn it. In some, yes. Okay. Now listen. Listen again. Listen again. Okay. Now, the idea is this. Listen. Listen. Now, the idea is this. Now you can clearly see why this is called traveling microscope. Right? It has a microscope here. It has a microscope here, and it can be moved vertically and horizontally. This microscope part can be moved vertically, and this entire pillar, this post kind of the part, can be moved horizontally. So therefore, since it can be moved vertically and horizontally, that is called a traveling microscope. That is called a traveling microscope. Right? Other than that, this microscope part can be rotated. It is like this. This microscope is fixed to look at the board, look at here. This microscope is fixed to dish like this, and this can be rotated as we need, as per our requirement. This can be rotated around this pivot point. Around this pivot point, it can be rotated like this. Here, right? This part can be rotated like this around that pivot point. It can be rotated, right? Okay. So we will see how a measurement is taken using the traveling microscope, right? Step by step. Just know that traveling microscope is specially designed to measure internal and external diameters of rubber tubes. Listen. Traveling microscope is specially designed to measure external and internal diameters of rubber tubes. Rubber tubes. Very important. Rubber tubes. The reason is, in other instruments we had like vernier caliper, micrometer, screw gauge, and spirometer. Now we have to tightly keep the object in between 2 points. If there is a vernier caliper, you have to tightly keep the object between external jaws or internal jaws. And if there is a micrometer screw gauge, you have to tightly keep the object to be measured between anvil and spindle. But here, the difference and the main advantage is we can keep the object on a stand in front of the microscope. We can keep the object in front of the microscope on a stand, on a separate stand. So therefore, no need to keep it tight. Therefore, especially this instrument is used to measure diameters of rubber tubes, because rubber tubes are deformative. Deformative in the sense it changes shape very quickly if you apply a force. Rubber force apply. If you apply a force, it changes its shape. So therefore, it cannot be kept tightly between any two of those. So therefore, that is why, especially this is designed in such a way that we don't need to keep this tightly in between any two points to measure it. Right? So therefore, especially this is used to measure rubber tubes. Right? To measure diameters of rubber tubes. Rubber, not glass tubes. For glass, vernier caliper can also be used. Micrometer screw gauge can also be used. For rubber tubes, only traveling microscope. Other than that, this can be used to measure capillary tubes. Capillary in the sense, capillaries are very small tubes. Then capillary tubes. Capillary. Capillary tubes are very small tubes. Since this consists of a microscope, we can see those endpoints and edges very clearly. Right? So very clearly you can see the edges. Therefore, to measure diameters of capillary tubes also, traveling microscope is used. Right? Other than that, the other main usage of a traveling microscope is to measure liquid meniscus. Have you seen liquid meniscus? If you put a liquid to a capillary tube, the liquid will be like this. It is curved. At the top surface. Right? The liquid will be curved at the top surface. That is called a liquid meniscus. To measure radius of liquid meniscus also, traveling microscope is used. So likewise, it has its own unique readings that can be taken from a traveling microscope. Own unique readings. Very unique. Very unique readings that can be taken by a traveling microscope. So other than these things, to measure thickness also, this can be used, but that is not a special reading, because to measure thickness you have no other instruments like vernier calipers. Vernier caliper depth measuring node use karona thickness එක measure කරන්න පුළුවන්. You can measure thickness using depth measuring pin of the vernier caliper, or you can measure thickness of a glass block using micrometer screw gauge, and other than that you can measure the thickness of a glass block using spirometer. Right? Now, using this also it is measurable, but there is not a special reading. Right? There is an additional reading that can be taken. These three are the special readings, 3 special and 3 unique readings that is taken by a traveling microscope. Unique in the sense, these 3 readings cannot be taken by other instruments. Is it clear? These readings can be taken using other instruments. This is only from the traveling microscope. Okay. Right. Now let's go to the note. Let's go to the note. First point. Write down the note one by one. Write down the note one by one. First point. First point. First point. To measure internal or external diameters. To measure internal or external diameters. To measure internal or external diameters of rubber tubes. To measure external or internal diameters of rubber tubes. Comma. To measure internal or external diameters of capillary tubes. To measure internal or external diameters of capillary tubes. And to measure positions of liquid meniscus. To measure positions of liquid meniscus. And to measure positions of liquid meniscus. And to measure positions of liquid meniscus. And to measure positions of liquid meniscus. This is called liquid meniscus. Huh? I hope you know the spelling. Liquid meniscus. Liquid meniscus. To measure positions of liquid meniscus. Traveling microscope is mostly used. Traveling microscope is mostly used. Traveling microscope is mainly used or mostly used. Traveling microscope is mostly used. Right? Next point. Next point. Main part of a traveling microscope. Next point. Point 2. Main part of a traveling microscope. Main part of a traveling microscope is the microscope. Main part of the traveling microscope is the microscope. Main part of the traveling microscope is the microscope, which consists of two convex lenses. Which consists of two convex lenses. Which consists of two convex lenses. It is like this. It is like this. Both are convex lenses, and this is the eyepiece. This is to keep the eye like this. That is to keep the eye, and this is the objective piece. Objective piece is to keep the object that you are going to measure. Right? You have to keep the object in front of the objective piece. Right? Take this down. Take this down. This part. This is an eye. Eye. ලස්සනයිද sir? One student has sent the diagram. ලස්සනයි ඔය ඕකේ මේ adjustments අඩුයි. ඔව් දෙක බඳලා තියෙන මේක හදන්නේ fine adjustment එක දාලා නැහැ. horizontal fine adjustment එක දාලා නැහැ. Hari, hari. Okay, good. So make sure you are copying down this properly, right? So if you miss any parts, uh, you will miss it. Then when you check for the name of the part or the mechanism of that part later, then you might get confused if you haven't marked these parts properly, right? So make sure you are marking everything properly. Last now that. And double check your label in with parts. Correct? මොනවාරි label එකක් miss වෙලා තිබ්බොත් එම ආයෙ හොයාගන්න බැරි වෙයි. ඊට පස්සේ double check කරන්න හැම part එකක්ම. Very important. Okay, next. Next point. Next point. Next point. Eyepiece is used to. Next point. Eyepiece is used to. Eyepiece is used to keep the eye. Eyepiece is used to keep the eye. Eyepiece is used to keep the eye. Right? Next point. Objective piece is used to. Next point. Objective piece is used to. Objective piece is used to keep the object. Objective piece is used to keep the object. Right? Next point. Next point. Next point. Traveling microscope consists of. Traveling microscope consists of. Traveling microscope consists of two vernier scales. Traveling microscope consists of two vernier scales. Traveling microscope consists of two vernier scales. Two vernier scales. Traveling microscope consists of two vernier scales. Right? So below that, number 1. Then 1 to the put 1 and 2 and write 1 vertical vernier scale. 1 vertical vernier scale. Vertical vernier scale. And number 2, horizontal vernier scale. Horizontal vernier scale. Right. Listen again. Now, when you move this part, right here, when you move this part vertically, only the vertical vernier scale works. And when you move this post horizontally, only the horizontal vernier scale is used. So otherwise, both movements cannot be done at once. Right? Only one movement at a time. Only one movement at a time. If you are moving this horizontally, you can move it horizontally along this scale. If you are moving this part, vertically, if you are moving this part vertically, you can move this part along the vertical vernier scale like this. And if you are moving this part horizontally, you can move it along the horizontal vernier scale like this. Right? Only one movement at a time. Only one movement at a time. Only one movement at a time. It's clear, right? Only one movement at a time. As the next point, write down with an asterisk mark. Next point with an asterisk mark. Write down. Next point with an asterisk mark. Write down. Vertical vernier scale is used to. Vertical vernier scale is used to. Vertical vernier scale. Vertical vernier scale is used to vertical movements of microscope is used to vertical movements of microscope and horizontal vernier scale and horizontal vernier scale is used to horizontal movements of microscope and horizontal vernier scale is used to horizontal movements of microscope. Right? Next point. Okay. Write down first, then I'll explain. First, write this down. Crosswires, like this. CR is crosswires. Right now. Crosswires of microscope can be seen. Crosswires of microscope can be seen. Crosswires of microscope can be seen when looking through the eyepiece. Crosswires of microscope can be seen when looking through the crosswires. Sorry, when looking through the microscope. Repeating again. Crosswires of microscope can be seen when looking through the eyepiece of microscope. Crosswires of microscope can be seen when looking through the eyepiece of microscope. Right? Crosswires of microscope can be seen when looking through the eyepiece of microscope. The idea is like this. There is a mechanism. Listen. There is a mechanism that is built inside the microscope. To make it easier to direct it to a point. To direct the microscope to a point, there's a small strategy, a tip, a technique is inside the microscope. That is called a crosswire. Which means now inside this microscope, in the middle of microscope, two wires are inbuilt as they are perpendicular to each other. Right? Two wires are there like this as they are perpendicular to each other. Therefore, when we look through the eyepiece, this is what we see. When we look through the eyepiece, we will see crosswires like this. When we look through the eyepiece, you will see crosswires. Unlike a traditional microscope, this microscope is used to take readings. Right? Now, about the microscope that you have used in grade 6, 7, 8, 9, those microscopes are just to observe cells or something like that. Just to observe cells, not to measure. But here, the purpose is measuring. In our microscope, the purpose is measuring. So therefore, we should be able to point out a point, pinpoint a point clearly to start taking measurements. Right? Measurement tag, point tag, direct you should be able to point it to a point. Right? Point it to a point. So that is why this mechanism is used. Now we have a intersection point, and that's a common point, and that's the indicator, that's the indicative point that we'll be using when we are pointing it to a point. Right? So we will see crosswires when you look through the microscope, and the purpose of crosswires is to make it easier when we direct it to a point. Right? We can pinpointly consider a point using this mechanism of the crosswires. They are called crosswires. Right? They are called crosswires. Okay, take it down. Write down. Okay. Next point. Next point. Principle used in. Next point. Principle used in. Principle used in traveling microscope is vernier principle. 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 Right. Next point. Next point. Main scale of traveling microscope. Next point. Main scale. Main scale of traveling microscope. Main scale of traveling microscope is calibrated in. Is calibrated in. Main scale of traveling microscope is calibrated in. Half millimeter divisions. Half millimeter. Half millimeter. 0.5 millimeter. Main scale of traveling microscope is calibrated in half millimeter divisions. And vernier scale consists of. And vernier scale consists of. And vernier scale consists of. And vernier scale consists of 50 divisions. 50 divisions. And vernier scale consists of 50 divisions in a typical traveling microscope. Vernier scale consists of 50 divisions in a typical traveling microscope. Right. Typical traveling microscope. I haven't shown you the traveling microscope. I'll show you now. Okay, write this down. Consists of 50 divisions in a typical traveling microscope. Okay, next heading. Next heading. Least count of traveling microscope. Next heading. Least count of traveling microscope. Write down. Least count of traveling microscope. Least count of traveling microscope. So you know, least count of any instrument which uses a vernier principle can be used as one division of main scale or number of vernier scale divisions. No? Same thing applies here. There are no circular divisions here. They are just linear divisions and very much similar to what you have in a vernier caliper. In vernier caliper, we have only one vernier scale. Here we have two vernier scales of similar type. Two vernier scales of similar type. Right? So least count can be written as, look at the board. Least count. Least count can be written as one division, no? Main scale over number of vernier scale divisions. Right? Or number of vernier scale divisions. This is the equation. This is the equation. Now, if I apply this equation to traveling microscope, you can find the least count of traveling microscope. The least count is. Point it and tell me. Yeah. Students, quickly. Find the least count. First take this down and then find the least count here and tell me quickly. Find the least count. Any questions up to here? Students, anything to clarify from the parts we discussed up to this point? Is there anything about traveling microscope? You should leave the class with no doubts, right? So that's why I'm asking. If you have anything to clarify, you can ask and get it clarified before leaving the class. All good, clear. Zero point zero two, 0.01. Okay. This count. This count is one division of main scale, half millimeters. Over number of vernier scale divisions, 50. Which means this count equals half of 50 means 100 millimeters. So this count is 0.01 millimeters. 0.01 millimeters. Right? 0.01 millimeters. Right? That's a normal thing, 0.01 millimeters. Right. So before moving on to the next part, let me show you the instrument. Showing means now, unlike the other instrument, I don't have an actual traveling microscope. Right? I showed you all of the instruments now. Vernier calipers, micrometers, screw gauges, spirometers. I showed you the real instruments. But for the traveling microscope, I will show you an image. The reason is compared to other instruments, traveling microscopes are very expensive. Right? Now, it's only used for laboratory purposes. Therefore, buying a traveling microscope is not useful for day-to-day things. Right? Day-to-day traveling microscope taking the cost is around like 4 lakhs to around 1 million. Traveling microscopes, starting from like 4 lakhs. And with the quality and some other things, there are instruments up to 1 million. The instruments are like not that expensive. Vernier calipers are around like 2,000, 3,000, and micrometer screw gauge is also around like 3,000, 5,000 in that range. Spirometers are also around the range of 2,000, 4,000. So they are comparatively cheap, but traveling microscopes are very expensive, but more than 4 lakhs minimum. Right? Okay, I'll show you an image. Give me 2 minutes. Give me 2 minutes. I'll show you an image. Traveling microscope. Okay. Is it visible now? It's visible, right? Students? Yeah, visible. Okay. Look at here. Look at here. Now, this is a typical traveling microscope. This is a typical traveling microscope. Look at here. Look at here. This is a typical traveling microscope. Now, identify these parts again. This is the microscope, main part. You can see this spotlight, the laser, right? This is the microscope. And this lens here, this one here is the objective piece. Objective piece. And the lens here, that is the eyepiece to keep the eye. And this is the adjustment I showed you. This is the adjustment of microscope. There is the adjustment of microscope. Right? This is the adjustment of microscope. Once this is adjusted, the distance between eyepiece and objective piece is changing. Right? Adjustment of microscope. And you can see the scales here. See, this scale is the vertical main scale. This one here. Vertical main scale. I have marked it here. Vertical main scale. Vertical main scale. And this part here, this part here is the vertical vernier scale. Vertical vernier scale. Right? And here, from here to here, you can see the horizontal scale. That is the main horizontal scale. Main horizontal scale or horizontal main scale. And this part is horizontal vernier scale. Right? Horizontal vernier scale. Right. Then about the adjustments, this part here at the very top. You can see this part here at the very top is the fine adjustment for the vertical movement. Fine adjustment for the vertical movement. I have drawn it here. Fine vertical movement. When this is rotated, this part, this black color part consists of microscope, goes up and down when we rotate it. This black color part consists of microscope, goes up and down. Right? The black color part goes up and down. Slowly, yeah? For slow movements. Fine movements means slow movements. And this is the force movement adjustment. See? I told you, I explained before. That's a lock. Once that part is unlocked, this one here, once that part is unlocked, this black frame is free to move manually. Manually in the sense you have to grab it and you have to move it. You can move it in a faster manner. Right? Grab it and move it in a faster manner. Right? And then here, this is the adjustment for fine horizontal movement. Once that is rotated, this entire part, මෙන්න මේ part එක. See, this entire part moves horizontally like this. This entire part moves horizontally like this, back and forth. This entire part moves horizontally like this, back and forth. Once this adjustment is adjusted, once the adjustment is rotated, once the horizontal adjustment for fine movements is rotated, that entire part goes right and left to the right and left horizontally. That is for fine movements. And if I need to move it faster, that is also here. You can see a knob here. See? Sorry. You can see a knob here. This one. This one. You can see the knob here. Now, that is the adjustment here. That is the adjustment here. That adjustment is for force horizontal movements. Force movements are the faster movements. Force movements are faster movements. Now, once that is rotated, that part will be unlocked. Once that is unlocked, you can grab it and move it here and there manually along that rail. Railing along that railing you can move it manually if you unlock this one from that force movement, right? Okay. Other than that, these two are the leveling screws, and there are 4 leveling screws. And in this diagram that I am showing you, only 2 are adjustable. Only 2 are adjustable. Although there are, even though there are 4 leveling screws, right? Different instruments are there. There are instruments which are having all 4 adjustable screws, and sometimes 2 adjustable screws like this. Now in this diagram, only 2 adjustable screws. See, only 2. Now by rotating these two parts, the height of the leg can be adjusted. Height of that leveling screw can be adjusted. The purpose is to level the instrument, right? And the leveling spirit level cannot be seen in this diagram. That is behind this setup. Leveling screw spirit level. So that cannot be seen in the diagram because that is a front elevation. In different instruments, that will be in different places. Now what I have drawn is an instrument with the level spirit level is in front of the instrument. In some instruments, that is behind the instrument. Now here that is behind, right? That is behind. And as one student asked, in some instruments, a small hand lens or a convex lens is also fixed here to see these divisions clearly in some traveling microscopes, right? The idea is the vernier scale here is divided into 50 divisions. Vernier scale is divided into 50 divisions. Since that is divided into 50 divisions, to check these divisions very clearly, right? Right? If I compare it with the vernier caliper, in vernier caliper, that is divided only for 10 divisions. Here that is divided to 50 divisions. So therefore, to see it properly, in some traveling microscopes, a hand lens is already fixed in built, right? So that's a traveling microscope, right? So this is how a typical traveling microscope looks like. This is how a typical traveling microscope looks like. Okay. Any questions? Any questions before moving on quickly? Any questions before moving on, students? Any other thing to know? Any questions before moving on? Or is it clear enough? No. Clear, right? Okay then. Okay, good. Okay, let's move on. Let's move on. As the next heading, write down. Next heading. Preparation of traveling microscope. Write down. Next heading. Preparation of traveling microscope. Preparation of traveling microscope. Preparation of traveling microscope to take readings. 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 Okay, there are few steps, right? So you will write one by one. So as number 1, write down. Number 1, write down leveling microscope. Number 1, leveling microscope. Number 1, leveling microscope. Write down the note below this step. Number 1, leveling microscope. Under that, write down first point. First point below this. Write down the spirit level. The spirit level. The spirit level should be used to. The spirit level should be used to. The spirit level. The spirit level should be used to level the instrument. The spirit level should be used to. The spirit level should be used to level the instrument. The spirit level should be used to Level the instrument. The spirit level should be used to level the instrument. Second bullet. Second bullet point. Level and screws of traveling microscope. Second point. Second point. Level and screws of traveling microscope. Level and screws of traveling microscope should be adjusted. Level and screws of traveling microscope should be adjusted by checking the air bubble of spirit level. 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 Right. Step 2. Step 2. Adjusting crosswires. Right now. Adjusting crosswires. Adjusting crosswires. Right. So under that, write down. Under that, first bullet, write down. Take a clear image of. Take a clear image of. Take a clear image of crosswires. Take a clear image of crosswires by looking through. Take a clear image of crosswires by looking through the eyepiece. By looking through the eyepiece and adjust it. Until intersection point of crosswires is symmetric in the image seen. Symmetric in the image seen. Symmetric in the image seen. Right? So it is like this. If it is not properly adjusted, you will see something like this. If it is not properly adjusted, you will see different diagrams like this. But if there is properly adjusted, it will be symmetric. It will be symmetric like this. Right? These are wrong. So it should be symmetric like this before taking the measurement. Take it down. Take it down. Okay, next heading. Next heading. Write down determination of. Next heading now. Next heading. Determination of internal radius of. Determination of internal radius of. Rubber tube. Determination of internal radius of rubber tube using traveling microscope. Take down the heading. Determination of internal radius of traveling microscope. Sorry, determination of internal radius of rubber tube using traveling microscope. Determination of internal radius of rubber tube using traveling microscope. Okay. Look at the board. Look at the board. Now, first thing is, listen. First thing is, we have to set up the instrument like the traveling microscope should be kept on a horizontal plane. And now preparation is done. In the preparation, now you have leveled the instrument. You have leveled the instrument, and now you can see this symmetric image of crosswires, right? And now you have to keep the traveling microscope on a table or a horizontal surface, and you have to fix the object that you are going to measure on a stand in front of traveling microscope. On a stand in front of traveling microscope, right? So once the setup is done, it looks like this. Now, if you need to rotate this, you can rotate. I told you, right? When you need to rotate this traveling microscope, the microscope part can be rotated. Microscope part can be rotated like this, right? Whether a pivot point at this is a pivot point. So around that pivot point, it can be rotated, right? Now, once it is rotated, this is how it looks. This is the microscope part. And on the same line, I just draw the microscope. On the same line, this tube that you are going to measure the radius of should be on a stand like this. Should be kept on a stand like this. Should be kept on a stand like this. In front of the instrument. Right? In front of the instrument. Like this. Right? Can you see? This is the microscope. And this is the rubber tube. And this is the stand. Right? And microscope microscope is here. Right? And if I need to observe a horizontal plane, you can rotate this like this and observe the horizontal plane like this. So in front of the microscope, now this stand is kept. On the stand, I have fixed the rubber tube that is going to be measured. Rubber tube that is going to be measured. Is it clear, students? And we are going to keep the eye somewhere here. Make eyepiece setting. We are going to keep the eye somewhere here. That is the eyepiece. Is it clear? Quickly. Is it clear, students? Yes. Okay. Write down first. Write down first. Set up the instrument. Write down first point. Set up the instrument. Set up the instrument. Set up the instrument. As microscope and set up the instrument as microscope and capillary tube. Set up the instrument as microscope and capillary tube. Microscope and capillary tube. Slash rubber tube. Capillary tube slash rubber tube. Capillary tube slash rubber tube are in the same horizontal line. Horizontal axis के लिए are in the same horizontal axis. Are in the same horizontal axis. Right? There are the instrument as microscope and capillary tube slash rubber tube are in the same horizontal axis. Okay, now take this down. Take down the diagram. Take it down. Take it down. Right? Okay. As an extending, write down as number one. Put number one and write down determination of vertical diameter. Determination of vertical diameter. Determination of vertical diameter. Right. Determination of vertical diameter. Determination of vertical diameter. Okay. Look at the board. Page name. Page. Okay. Look at the board. Look at here. Now this is how the rubber tube is visible when we look through the microscope. This is how the rubber tube is visible when you look through the microscope, because now we are keeping the rubber tube as it is face to the microscope. So this is how it is visible, right? And this part is the thickness of this rubber tube now. This is the thickness of the rubber tube. This is how it is visible, right? Now first what we do is we are taking crosswires to the topmost point here like this. We are taking the crosswires to the topmost point. So let's say this point is A, right? And we have to take the reading accordingly. Now let's assume the reading here as R1. Let's assume the reading here as R1. And then the second step is without moving, listen, without moving the horizontal scale or without changing positions of the traveling microscope, without moving the horizontal scale, we are moving the vertical scale, only the vertical scale, to this point until crosswires are coming to the lowermost point. Let's say point B, and here the reading is R2. R2. Listen. Now, I told you we are moving only one scale at a time. Only one movement at a time. Movements දෙකක් තිබ්බ කියලා දෙකම එකපාර move කරන්න බෑ. You can't move both movements simultaneously, even though there are no movements. Only one movement at a time, right? Now, since I need to get the vertical diameter, my interest is on vertical diameter now. Now, vertical diameter is between these 2 points, right? What I'm going to measure is internal vertical diameter. Internal vertical diameter. So therefore, now the traveling microscope is like this now. It is kept in line with the rubber tube. So once we have taken it to the position A, and if you need to take it to position B, by rotating the fine movement, you are taking this down slowly. Taking this down slowly until the crosswires reach this point. Until the crosswires reach this point. So likewise, that reading can be taken. Now, here I have moved the microscope vertically. When we are using the microscope vertically, you have to use the vertical vernier scale. Right now, there is no horizontal movement at this instance. So therefore, horizontal movement is locked now. Right? It is locked. Vertical movement moves. So therefore, since there is a vertical movement, we will require the vertical scale. Vertically, simple as that. When we use it vertically, when we move it vertically, vertical scale will be ready. Right? Okay, take it down. Take it down. Take it down. And label them as A and B. Label them as A and B. Write down. Questions. Done. Okay. Okay. Somewhere here or here, somewhere around the diagram, write down. Somewhere here, this side or that side, as you have space, write down. Use vertical vernier scale. Write down. Use vertical vernier scale. Use vertical vernier scale when microscope moves vertically. Use vertical vernier scale when microscope moves vertically. Use vertical vernier scale when microscope moves vertically. Right. First point under this. First point. First focus microscope to. First focus microscope to. First focus microscope to point A. First focus microscope to point A at internal surface of rubber tube. First focus microscope to point A at internal surface of rubber tube and take the reading and take the respective reading and take the respective reading R1 and take the respective reading R1 and take the respective reading R1 and take the respective reading R1. Right. Second point. Then focus. Next point. Then focus. Cross wires of microscope to. Then focus. Cross wires of microscope to. Then focus. Cross wires of microscope to. Point B at internal surface. Point B at internal surface and take the reading R2. Point B at internal surface and take the reading R2. And take the reading R2. Next point. Vertical diameter is given by. Next point. Vertical diameter is given by. Vertical diameter is given by the difference between. Vertical diameter is given by the difference between above readings. Vertical diameter is given by the difference between above readings. Right. So it is like this. So get here. Let's say the vertical diameter is D1. Therefore, vertical diameter equals, let's say D1 equals R1 minus R2. Right. Vertical diameter equals R1 minus R2. Right. Because when the traveling microscope, when the traveling microscope is moving from here to here, it moves vertically, exactly from point A to point B. Right? Point A is the topmost point of the rubber tube and point B is the lowermost point of the rubber tube. So the distance between point A and point B has to be a vertical diameter. That is the idea. So if you take this reading difference of readings, you will get this value. Right? If you are moving it from below to up or bottom to top, subtract from the second reading, subtract the first reading from the second reading. So likewise, simply the idea is like this. Subtract the lower value from the greater value. Subtract the lesser value from the greater value. හරි මෙතන ඩිෆරන්ස් එකනේ හොයාගන්න ඕනේ. එළිම ඩිෆරන්ස් එක හොයාගන්න මොකද හිතන්න දෙයක් නැහැ. higher value එකෙන් lower value එක subtract කරලා දාන්න. Then you will get the vertical diameter like this. Is that idea clear, students? Is that idea clear? Tell me quickly. Is that idea clear? Tell me quickly before moving on. Are you clear about the idea? Clear. Clear. Okay, all good. Right. Explain it again. Explain it again. Okay. Listen again. Listen again. Listen again. Now here initially I have focused the traveling microscope to point A, topmost point of the rubber tube, right? And the microscope will be like this now, right? It is focused. May I understand it? Traveling microscope is focused like this, and the rubber tube is on the stand like this in front of the microscope. And I have focused that microscope to point A of the rubber tube, and we are taking that reading, and then we are taking this down until the crosswires are focused to the bottommost point like this. Until crosswires are focused to the bottommost point like this. And once that is at the bottommost point, we can take that respective reading, R2. Right? Now, from here to here, traveling microscope has moved vertically, like this, from here to here. Right? The difference of readings will be exactly this vertical diameter. මෙතන තියෙන reading එකේ මෙතන එකේ difference එක ගත්තා නම් මෙන්න මේ height එක එනවා. That will be the vertical diameter. Right? That's a simple idea. Understood? Right. Then number two. Determination of. Write down. Number two. Determination of horizontal diameter. Determination of horizontal diameter. More or less the same thing. More or less the same thing. Look at the board. Right. To determine the horizontal diameter, what is being done is first we are focusing crosswires to here. Let's say D, C, and then we are focusing the crosswires to here. Let's say position D. Let me go. Stop. Sorry. First, focus crosswires to position C. Like this. Focus crosswires to position C like this. Here. Let's say C. And then to D. Like this. Let's say D. Right. And same thing again. Let's say the reading here is R3. And let's say the reading here is R4. Right. Now, when we measure horizontal diameter, listen. When we measure horizontal diameters, microscope will be moved horizontally. Only horizontally. Like this. Microscope will be moved horizontally. Right. So therefore, no vertical movement is done. And only a horizontal movement is done using fine horizontal movement. Right? Using fine horizontal movement. And we are going to take these two readings by moving the microscope horizontally. Right? Then for that, horizontal vernier scale will be used. Right? Take it down. Take it down. Another small announcement. Listen, another small announcement. Since most of you asked about the website and the registration for this month, yeah, now the developing part of the website is finished, right? Developing part of the website is finished, and some of the updates are going on. Updates means creating classes and some interfaces and some updates are going on, right? So it will be available to register next week onwards, right? Before next week, actually. Before next week, it will be available to register. And developer is still working on those, the final updates, right? Now, from my end, the website is working, but I didn't launch it yet because some of the final updates are going on, right? So before week 2, I'm planning to launch it. Once it is launched, you can go there and join the class, right? And if there's anything happens or if we ran out of time before next week to complete it before next week, I'll give you an update through the group. Otherwise, now if nothing unexpected happens, we'll be launching the website in 3-4 days, most probably 3-4 before next week. Somehow we are going to launch it. Once it is launched, registrations, enrollments, watching recordings, joining to classes, right? Everything will be done using the website only, right? Yeah, some of you asked because I saw there were some students who have paid the fee already, right? Now, for them, what you can do is if you have paid the fee already, keep that slip with you, pay slip with you, because once you are registering to the website, you can upload that same slip there and complete the registration, right? So make sure you have the clip, you have that pay slip with you, right? Registration pay කරලා නම් තියෙන්නේ already, slip එක මතක කරගන්න තියාගන්න. ඒක upload කරන්න වෙයි website එකට. Right? Finished? Finished? Okay, mention somewhere here, mention somewhere here. Use horizontal scale. Use horizontal scale. Use horizontal scale. When microscope moves horizontally. Use horizontal scale when microscope moves horizontally. Use horizontal scale when microscope moves horizontally. Use horizontal scale when microscope moves horizontally. Right. So under that, point 1 again. Point 1 again. Under that, point 1 again. Now focus crosswires. Point 1. Now focus crosswires. Now focus crosswires of microscope 2. Point C. Now focus crosswires of microscope 2. Point C. And take the reading R3. And take the reading R3. And take the reading R3. Next point. Next point. Then focus crosswires. Next point. Then focus crosswires. Then focus crosswires to point D. Then focus crosswires to point D at internal surface. Point D at internal surface. And take the reading R4. And take the reading R4. And take the reading R4. Next point. Next point. Horizontal diameter is given by. Next point. Horizontal diameter is given by difference between above readings. Horizontal diameter is given by difference between above readings. Horizontal diameter is given by difference between above readings. Right? Horizontal diameter is given by difference between above readings. Right. Now, very similar to the previous case. It is like this. If you need the horizontal diameter, let's say horizontal diameter is D2. Horizontal diameter. Let's say D2. That is given by R4 minus R3. Measure it. Take it out. And now what we have is this. What we have got already is this. These two values are known now. From the rubber tube, vertical diameter is known D1 and horizontal diameter is known D2. Right? Vertical diameter is known and horizontal diameter is known. To get a more accurate value, we are taking the average of these two, right? To get a more accurate value. Because especially when it comes to rubber tubes, it can be deformed. So therefore, we are taking two perpendicular readings and getting the average to be more accurate and to be more reasonable. Right? The reason is if you take diameter from one point, right? What can happen is if in case if the rubber tube is deformed, if it has changed the shape, we will get a comparatively erroneous reading, a reading with an error. So therefore, we are usually taking two readings in two perpendicular directions and getting the average. Right? Higher the number of readings we can take, higher the accuracy. Right? Okay, next point. So it should be R3 minus R4, right? No. Now, if I'm moving it from left to right, in the left side, towards the left side, 0 is mentioned towards the left side. So if you are moving from left to right, it will be R4 minus R3. Simply, once you have these values, no need to get confused. Once you have these values, you can see which value is higher and which value is lesser. Always subtract the lesser value from the higher value. Simple as that. Right? Because it depends in the direction of movement. Now I moved from left to right. If you move from right to left, it will be different. So therefore, subtract the lower value, lesser value from the higher value. That's it. Clear? Okay, next write down. Therefore, next point. Therefore, if internal radius of capillary tube is therefore, if internal radius of capillary tube is simple D. Therefore, if internal radius of capillary tube is simple D, put a comma and write down D equals D1 plus D2 over 2. D equals D1 plus D2 over 2. And you can take this down as well. This one. You can take this down as well. This diagram, only this diagram. Take it down. Okay. Done. Mention this below with a red pen. Put an asterisk mark and mention this point. Right, mention this below with a red pen. Put an asterisk mark and mention this point. Mention. Put an asterisk mark and mention this point. To minimize random errors. To minimize random errors. Right, using a red pen. To minimize random errors. To minimize random errors. Average value of to minimize random errors. Average value of two perpendicular readings. Average value of two perpendicular readings. Average value of two perpendicular readings are considered. Average value of two perpendicular readings are considered. Right. Listen again. As a note, write this down. As a note, write this down. As a note, write down. Zero errors of, write down. Zero errors of, as a note, write down. Zero errors of traveling microscope is zero errors of traveling microscope is also same as that of vernier caliper. Zero errors of traveling microscope is also same as that of vernier caliper. Zero errors of traveling microscope is also same as that of vernier caliper. Listen now. The reason is in traveling microscope also we have two linear scales. Linear main scale and linear vernier scale. So from vernier principle, from vernier caliper, you know that if the vernier zero is shifted to left, that's a negative zero error. If the vernier zero is shifted to right, that's a positive zero error. Reading zero errors is exactly same as vernier caliper, right? The only addition here is there are two scales like vertical scale and a horizontal scale, right? But for both scales, that method is same. So therefore, we are not going to discuss about zero errors of traveling microscope separately because that is exactly same as vernier caliper, right? Then with that, that's the end of the theory parts that we have discussed about traveling microscope. End of theory parts. Right. Tell me if you have any questions. Any questions? Any questions? Anything to know? Anything to clarify? Anything to know? Okay, so at least put the thumbs up, a reaction, then I know whether it's clear. So what about the ones on YouTube? This one's on YouTube. Is it clear for you as well? Oh, good. Okay. Oh, clear. Okay. Good. Good. Okay, we'll do a question. Write this down. Write this down. Write down this question. A question. Write down. Uh, okay, right here. Right here. Okay, can you hear me, students? Can you hear me, students? Okay. Okay, I'm not sure what happened. Suddenly the Wi-Fi got disconnected. Right? Yeah. I'm not sure what happened. Suddenly Wi-Fi got disconnected. Okay, now it's fine. Now it's fine, I guess. Yeah. Now it's fine. Okay. Take it down. Take it down. Take it down. Figure A and figure B. I haven't drawn all 50 divisions of vernier scale. I haven't drawn all 50 divisions of vernier scale. Only a part of the scales is drawn. Take it down. Only a part is drawn. Write down the question. Write down the question. Above diagrams show. I know. Above diagrams show. Above diagrams show. Above diagrams show positions of scales. 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 Of a traveling microscope. Of a traveling microscope. Of a traveling microscope. When a vertical diameter of rubber tube. When a vertical diameter of rubber tube. When a vertical diameter of rubber tube is determined. When a vertical diameter of rubber tube is determined. When a vertical diameter of rubber tube is determined. Right. Problem number one. Problem number one. Problem number one. What's the least count of traveling microscope? Problem number one. What's the least count? What's the least count of traveling microscope? Problem number one. What's the least count of traveling microscope? Right. Number two. Take the reading at figure A. Number two. Take the reading at figure A. Take the reading at figure A. Number three. Take the reading at figure B. Number three. Take the reading at figure B. Right. Take the reading at figure B. Number four. Number four. Determine vertical diameter of tube. Determine vertical diameter of tube. Determine vertical diameter of tube. Number five. Number five. Determine. Number five. Determine radius of tube. Determine radius of tube. Number five. Determine radius of tube. Okay. Try it quickly. Try it quickly. And I need same answers from all of you. And once you got answers, feel free to put them to the chat. Right? If you are on Zoom, put it in the Zoom chat. And if you are on YouTube, put it to the YouTube chat. Right? Wait, right, quickly. 3 minutes. 3 minutes. Quickly. Can you tell the first question? First question. What's the least count of a traveling microscope? What's the least count of a traveling microscope? Any answers? Anyone? Any answers? Any answers? First one. This count is easy. This count is one main scale division is half millimeter. So number of vernier scale divisions half over 50. Half over 50. 0.01 millimeters. 0.01 millimeters. Second one. Reading here. Any answers? Two के आंसर क्या टक्का? Two के आंसर साहब आंसर क्या? Two. Reading and figure A. Reading and figure A. Quickly. Any answers? Come on, students. Time is enough. Come on. Time is enough. What's the reading of 2? Figure 2. What's the reading of figure 2? Quickly. Anyone? Reading of figure 2. Quickly. Anyone? No answers? Quickly. At least one correct answer. What's the reading of figure B? Figure A. 31.02. One says 31.02. Okay. 31.02. Others? Is it same? One says 31.02. Is it same or any different answers? So we know any reading is, let's say, reading at A, RA, any reading is main scale plus vernier scale. Right? Main scale is completed main scale. Main scale is completed main scale. And in traveling microscope, we have divisions of half millimeters in the main scale. So this is 30 millimeters, this is 31, 32. 32 divisions are completed. Sorry, 30, 30.5, 31. So only 31 millimeters are completed. Because we have half millimeter divisions. Half millimeter divisions. 30, 30.5, 31. Half millimeters, 30.5, 31. So this is 31 plus vernier scale. Number of coincident divisions in least count 1, 2. Two divisions are coincided into least count 0.01 millimeters. Simplify this. 31 millimeters plus 0.02 millimeters. So RA is 31.02 millimeters. Yeah, that is correct. What about RB? RB? RB, anyone? RB. Reading here. Quickly. 50.01. 50.01. Let's see. Same thing again. Main scale plus vernier scale. Main scale is, yeah, 50. Only 50 is completed. 50 millimeters. Plus from vernier scale, first division itself is coincided. 0.01 millimeters. Then 50 millimeters plus from here 0.01 millimeters. That is 50.01 millimeters. Number 4. Diameter. Diameter will be the difference. Right? Simple as that. So the diameter is 50.01 millimeters minus 31.02 millimeters. Observe. Observe. $18.99. Correct diameter is 18.99 millimeters. 18.99 millimeters. And radius. Radius. Radius will be diameter over 2. 18.99 over 2. Nine point four nine. 9.49 millimeters. 9.49 millimeters. Right? Now, if your least count is two decimals, up to 2 decimals, you have to keep all answers up to 2 decimals. Right? 9.49 millimeters. So these are the old answers. Right? From traveling microscopes, normal questions are coming like this, very normal questions. And when it comes to MCQs, other than the calculations, statement type questions are coming, statements. And plus, in structured essays, traveling microscope questions are coming in structured essays. Right? So there you have to answer with the identification of parts, and with their functions, mechanisms, plus a calculation. That is how a structured essay question will be coming. Okay, take it down quickly. Take it down quickly. Finished? Any questions on this? Or is it clear enough? Any questions on this? So is it clear enough? All good up to this point? Okay. Now with this it marks the end of unit 1 measurements, right? And since measuring instruments are done, I'll give all the required things in a summary, and we are going to wind up this. Take down a note as summary. 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 And take it down in a table. Take this down in a table like this, in a tabular form table. First one, instrument, and here least count, and here maximum reading. Okay. Take it out. So first one, starting with meter ruler. First one, meter ruler. Okay, I need two answers quickly. What's the least count of meter ruler? Quickly. Now we are at the last day of unit 1, right? Last day of unit 1. Now you should be able to answer any question that I'm asking from unit 1, from the things we covered. Right? Tell me, what's the least count of meter ruler? Can everyone put it to the main chat? Then I can see it easily. Right? Yeah, put it to the main chat. Then I can see it very easily. Otherwise, I have to go near the laptop again and again to check your answers one by one. Yeah, 1 millimeter. Good. Please count 1 millimeter. And there is no maximum reading for meter ruler, but there is a minimum reading. What was the minimum reading of a meter ruler? To keep that percentage error at 1%. What was the minimum reading that is suitable to take from a meter ruler? We discussed on the first day. Quickly. 10 centimeters, not millimeters, 10 centimeters. Right? So mention here, suitable for readings above 10 centimeters. Suitable for readings above 10 centimeters. Right? Second one, vernier caliper. What's the least count of vernier caliper? Least count of vernier caliper. 0.1 millimeters. Maximum reading of vernier caliper. Maximum reading. We discussed. I showed you. Maximum reading of vernier caliper. Come on, students. And 10, 15, no? I'll be waiting until you give me correct answers. What's the maximum reading of a vernier caliper? 15 centimeters. Okay, good. 15 centimeters. Next one. Right, 15 centimeters. Next, micrometer screw gauge. Micrometer screw gauge. Least count. Quickly. Yeah, 0.01 millimeters. Maximum reading. Maximum reading. Maximum reading. Good. 25 millimeters. 25 millimeters. So, sperometer. Please count. 0.01 millimeters. Same. Maximum reading. Maximum reading of a sperometer. Tell me. What's the maximum reading of a sperometer? What's the maximum reading? Tell me. 10 millimeters. At least 10 millimeters each side. 10 millimeters each side. 10 millimeters each side. That's a center zero. From the center zero, 10 millimeters upwards and downwards. 10 millimeters each side. Traveling microscope. Maximum reading of traveling microscope is also same as vernier caliper. 15 centimeters. Okay. Copy it down quickly. This is a summary of all the instruments what we have done. Summary of all the instruments what we have done. Right. Write it down quickly. Finish. Done. Okay. Okay. So then with that, it marks the end of unit 1 measurements. Right. First part was units and dimensions, and second part of the unit was measuring instruments. Now we have completed all the things from the beginning, from A to Z. Right. From zero, from sketch, from A to Z. Now you have completed all the things from the beginning. Now this is the end of unit 1. As I told you, we are starting unit 2 in the next week. We are starting unit 2 in the next week. And I'll be arranging a question discussion from unit 1 measurements in one of the coming days. I'll be giving you all the updates through the group. Right? I'll be arranging an extra question discussion on measurements. Measurements lesson में क्या questions को discuss कराना. Right? Especially past paper questions. To discuss the past paper questions on measurements, I'll be arranging an extra class in a coming day. You are the new batch, and I have done the same for the regular batch as well. Right? So I'll be doing the same for your batch as well. You are the new batch, and you are going to merge into the regular batch after October. Right? That's why. Okay, now this is the end of measurements. You also can try questions, and you can see how the questions are coming from your end. And from my side, I'll be arranging you an extra session for the question discussion. Right? And next week, we are especially starting unit 2, mechanics, one of the most important lessons in our syllabus, as I told you. Right? Very important. And simply the most important, undoubtedly the most important lesson in the syllabus, mechanics, because it's connecting to all other units in the syllabus. That's the reason. Right? Okay. So if there's anyone who is willing to join the class from mechanics onwards, you can share the message among your friends and colleagues. Right? And next day we are starting mechanics, and I'll give you all other updates through your groups and the channels. Right? Okay then, if you are a new student, you make sure you are connected to the channels and groups to get all the updates. Okay. And once this live is ended, you also can go to my YouTube and put a comment on that YouTube video whether you got this lesson properly or not. Right? Whether you understood this lesson or not. Right? Then I can check the comments later and check whether you have understood the lesson or not. Right? I have conducted this as a free session, no? So therefore, I also need to check whether you have understood the lesson or not. If you have understood, you can put a comment if you have understood. If not, also, if there are anything that you didn't get from the discussion, you can put that as well as a comment. Doesn't matter it's good or bad. I just need a feedback to see whether you have got it or not. Right? So put that once the live is ended, because otherwise, if you put that onto the live chat will be disappeared once the live video is finished. Right? So therefore, once the live video is ended, go to the comment section and add a comment, right? Even though if you are on Zoom also, you can go to the YouTube and add a comment if you have understood the lesson properly. Okay, then yeah, it's time to wind up. We'll be starting mechanics next week, unit 2, mechanics next week, right? All right then, we'll be meeting on the next day, right? Good night and goodbye. Study hard, work hard, and stay safe, right? Goodbye.